to today's lecture. The lecture series that I am covering is of subject embedded system, code is AKtU 062. Myself Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The topic that I am covering today is serial bus communication protocols. Let us first understand what is the difference between serial data transfer and parallel data transfer. So, when we are talking about the serial data transfer, obviously it is the data transfer between the two terminals, one of them is sender and another is receiver. But when we are talking about the serial transfer, that means bits are sent serially from sender to receiver. Serially means one bit at a time, bit by bit transmission is done. On the other hand, when we are talking about the parallel transfer, obviously terminals are same, sender and receiver, but in the parallel transfer bits are sent parallelly, that is all the bits are sent at the same time using multiple lines of transmission. So, this is the basic difference between serial and parallel data transmission. Now, what are the detailed differences between the two? So, we have already understood that one bit at a time is transferred in case of serial communication and all the bits are transferred at the same time in case of parallel transmission. Now, when we talk about the speed is low in case of serial communication and here the speed is high in case of parallel communication. Why? Because in case of serial communication the bits are transferred one bit at a time and in case of parallel transmission all the bits are transferred at the same time. Obviously, the speed will increase when all the bits are simultaneously transferred. Now, it has the single transmission line, it has multiple transmission lines as it is clear from the diagram. As we can see, here are multiple transmission lines and it is having single transmission line. Serial communication do not have crosstalk problem. What is this problem? In the parallel transmission, since there are multiple lines and the bits are transferred simultaneously. So, on the single line when the bit is being transferred, it will obviously create some disturbance to its next line. So, since all the bits are transferred simultaneously on the different lines, so the bits can disturb other signals. So, this is known as the crosstalk problem. So, in the serial communication we do not have multiple lines for the data transmission, the data is sent serially one bit at a time. So, there is no point of crosstalk problem. Serial communication is less expensive and this is more expensive. Why? Because more number of wires are required in parallel communication, obviously the hardware will increase and it will add to the cost. Here the bandwidth is higher, here the bandwidth is lower. Next, it is not affected with the noise problems, it may suffer with noise problems as we have already discussed. Serial communication even works at higher frequencies, parallel communication may not work properly at higher frequencies. Why? Because at higher frequencies the problem of crosstalk becomes more and more prominent. So, we have to use the limited frequencies. So, for that purpose parallel communication is not so good. It covers long distance when compared to parallel communication. It covers short distance. So, the covering the short distance in case of parallel transmission, it has the 2 points. First one, since the parallel communication is using more number of wires. So, if we are covering the long distance communication using the parallel scheme, then obviously the hardware will increase and it will add to the cost. Secondly, when we are talking about the parallel communication, the crosstalk is another problem with that. With the higher frequencies, the crosstalk will increase, and with the longer distances, the problem becomes more prominent. So, we have to avoid the long distance transmission with parallel communication. Now, example of serial communication is the communication between the computer and modem. Parallel communication example is the communication between motherboard and hard disk. So, these are 2 points. So, these are the detailed differences between the two types of communication, that is the parallel and serial communication. Let us have some details of serial transmission. Bits of a byte are serially transmitted one after other, we know that. Shift register, this is another important point. Shift register is used for serial transmission. What is this shift register? The byte to be transmitted is first stored in the shift register. Okay. Then these bits are shifted from MSB to LSB. What is MSB and LSB? Most significant bit and least significant bit. Suppose we are having 8 bits of data. So, this is MSB and this is LSB. So, when that byte is stored in the shift register, then these bits are shifted from MSB to LSB bit by bit in synchronization with the clock. The bits are shifted right by one position per clock cycle. So, with one clock cycle, with every clock cycle, bits are shifted. So, in this way, from MSB to LSB, the bits are shifted in shift register, and thereby these bits are transmitted with every clock pulse. As an advantage, only one wire is used in serial transmission. Yes, this is advantage. This is the prevention of hardware, we can say. Now, this figure depicts the serial communication. Here is the sender, here is the receiver. Sender is having this data to be transmitted. So, first of all, this data will be converted into the serial data, and thereby it will be transferred. The purpose of conversion is fulfilled by using the shift register. So, here the parallel to serial conversion is taking place, then these bits are serially transferred from sender to receiver using only single line. Here the receiver again receives that data and converts that data back to the parallel scheme. Now, when we are talking about the advantages and disadvantages, advantages of serial transmission, only one wire is required, that is advantage, that is the saving of hardware. Reduction in the cost due to the less number of conductor wires. So, cost is indirectly or we can say directly related to the hardware. So, since the less hardware is used in case of serial transmission, so the cost will be low. It is the most used method for long distance data transfers. Yes, since there is no problem of crosstalk, so this transmission method can be used for long distance communication. Now, on the other hand, what are the disadvantages? Since there is only one line of transmission, so what will be the effect? The effect will be directly on the speed. Since the bits are serially transmitted from one point to another, so there will be a slower rate of transmission, speed will be low. If we have to increase the speed, now we want to increase the speed, then what we can do? We can increase the frequency, but increasing the frequency is not a good solution. There should be a limit to the frequency in every type of communication. So, that factor comes into picture, but there is a limit to clock frequency, that is. So, these were the certain advantages and disadvantages of serial communication. So, let us go into some details of serial communication. There are two categories of serial communication. First one is the asynchronous data transmission and another is synchronous data transmission. When we talk about the asynchronous data transmission, what do you understand by the term asynchronous? That means there is no synchronization between in the transmission, and when there is no synchronization means there is no clock. So, it means that this asynchronous data transmission does not need the clock. Examples are UART, telephone, modem, RS-232 communication between UART devices, that these are the examples of asynchronous data transmission. And the examples of synchronous data transmission, these are SPI and I2C. These we will cover in further lectures, and this also will be covered in further lectures. In the synchronous data transmission, what is the difference between these two mentions? In the synchronous data transmission, the clock will be used and the data transmission will be take place in perfect synchronicity. So, let us see. So, when we are talking about asynchronous serial transmission, that means in this the timing of the signal is not an issue. The information can be sent and received as per the mutual agreement of sender and receiver. So, the data transmission takes place between the sender and the receiver based on the mutual consent, and that is why the data is synchronized in this way, not using the clock. Asynchronous transmission is at byte level only, because transmission of the bits is always synchronized. So, within a byte the bits are synchronized within themselves, but there is no synchronization between the bytes. So, within the byte there is the synchronous attitude between the bits, but between the bytes there is no synchronization. Asynchronous transmission is eased by 2 bits, namely start bit as 0 and stop bit as 1. Since there is no clock used in asynchronous data transmission, so how will the data be synchronized? Using start and stop bits. So, whenever the sender is receiving is sending the data to the receiver, it will send the start bit before sending the data. So, the receiver will understand that now the data will start, and when it wants to stop the transmission, it will again send the stop bit. So, again the receiver will understand that the transmission is being stopped. So, in this way synchronization is attained between the sender and the receiver in case of asynchronous serial transmission. Since there is no usage of clock, so the synchronization in the case of asynchronous serial transmission is attained using start and stop bits, and as a standard start bit is always 0 and stop bit is always 1. We send 0 bit to start the communication and 1 bit to stop the transmission. There can be a time delay between the communication of 2 bytes, obviously there can be a time delay. Since there is no standard clock, there is no common clock between the 2 terminals. So, only 1 byte is sent at a time. After a gap of next byte, after a time gap, a simple time gap, there is then the next byte is transferred. So, in this way this problem is also controlled. What problem? The problem of having the time delay between the communication of 2 bytes. Since both the devices are not having a common clock, so this problem may occur, and to control this problem there a gap is left between the 2 bytes. So, in order to that compromise that delay. Now, the transmitter and the receiver may function at different clock frequencies. Obviously, this is one of the important points, that in case of asynchronous data transmission, the clock speeds, or we can say the clock frequencies of both the terminals, that is the receiver and the sender, these are different. Now, this figure is showing asynchronous serial transmission in the perfect way. There is the sender, there is the receiver, these are the data, these are the data bytes in white background, and in the light blue background, this one, these are the start and stop bits. So, obviously, the start bit is 0 and stop bit is 1. So, this is the complete frame which is being sent in case of asynchronous data transmission. These are the gaps, between the bytes, as I have already discussed. Why these gaps are introduced? To compromise the delay, if any, has been obtained between the two bytes. So, this is the direction of flow from sender to receiver. Why is it called asynchronous? As after so much of discussion, we should understand this very easily, that at the byte level the sender and the receiver are not synchronized, since there is no common clock. So, that is why it is known as the asynchronous transmission. However, within each byte, receiver should still be synchronized with the incoming bit stream. This means that some synchronization is required only during the duration of single byte transfer, not between the bytes, but within the byte there needs to be some synchronization. When we mention the advantages, it is a flexible data transmission method. Why it is flexible? Because no need of the clock, no need of having the same speeds between the sender and the receiver. So, there is bit flexibility, we need not to be precise enough. So, that is why this is flexible data transmission method. Synchronization between the transmitter and receiver is not necessary. This is another advantage, because achieving the synchronization is not an easy task, that needs a perfect clock, a perfect oscillators which may provide the precise clock. So, it is possible to transmit the signals from the sources having different bit rates. Obviously, this is also another advantage, that we need not worry about having the terminals with the different clock speeds. We can transmit the signals from the sources having the different, since there may be the multiple sources. So, it is possible to have the different sources with different speeds. We need not worry about having the same speeds. The transmission can commence as soon as the data byte to be transmitted becomes available. Obviously, since we need not judge when the clock tick occurs, as soon as the data comes, it can be transmitted. So, that is very flexible communication. This mode of transmission is very easy to implement. It is easy to implement. Why? Because there is no need of having the extra hardware, extra circuitry for the implementation of clock. So, this type of transmission mode can be easily implemented. It is an effective scheme. Yes, it is an effective scheme. It is cheap scheme in terms of money, since it saves the hardware for the clock arrangement and all. So, it is cheaper as compared to other. Now, disadvantage, obviously every system is having the disadvantage along with few advantages also. Additional bits called the start and stop bits are required, that is the overhead, that is the add-on that can be removed, but we need to have these start and stop bits in case of asynchronous communication, because this is the only way of achieving synchronization in case of asynchronous transmission. The timing error may take place because it is difficult to determine synchronicity. Yes, timing error can occur in this case, because we are not having clock, we are not using clock. The only way of achieving synchronization is using the start and stop bits. The sender and the receiver are having the different speeds, so obviously the timing error can occur. It has slower transmission rate. Why? Because along with the main data, there are the gaps, there are the start and stop bits. So, all these are adding to the time. So, obviously the speed decreases. Now, we come to the synchronous serial transmission. It is carried out under the control of the common master clock. This is the basic difference between the two schemes. Bits which are being transmitted are synchronized to the same reference clock. Yes. So, both the sender and the receiver are working under the same master clock. So, the bits, bytes, everything is synchronized according to the master clock. The stream of the bits is combined into bigger frames which may comprise of more than one byte. This is another important point, that in this the multiple frames can be sent and into the bigger frames. The bigger frames are having the multiple bytes to be sent. It is not like that in the, as in the case of asynchronous, that we were sending only one byte at a time and between the different bytes there was a certain gap. But in this case, in the case of synchronous serial communication, since it is working under the master clock, so it is possible to send the multiple bytes within a single frame. So, obviously the speed will increase. Each byte is transmitted without the gap between the next byte. There is no need of gap because there is no scope of asynchronous transmission. Now, so about this another point is no start and stop bits are used, because here the synchronization is achieved using the master clock. So, there is no need to send the start and stop bits. Instead, the bytes are transmitted as a block, as we have already discussed. These blocks are also known as frames or the packets. So, within the frame there are multiple bytes and they are spaced by the fixed time intervals in a continuous stream of bits. The receivers operates at the same clock frequency as that of the transmitter. That is a very important point. Here the clock is standard clock, the master clock. It is the duty of the receiver to separate the bits sent in the group. Okay, this is another point. There is an inter block idle time which also is filled with the idle characters. So, between the different blocks there is some idle time and this is also occupied using the idle characters. This is the look of transmission. Here you can see different bytes are being sent and they are contained within the blocks. So, this is quite simple transmission, since there is no start and stop bits. Also there is no gap between the different bytes and the direction of flow we can see from sender to receiver. When we talk about the advantages, the main advantage is speed, because there is a standard clock, there is no start and stop bits, there is no gaps, obviously the speed will increase. Due to the absence of the gaps between the data units and due to the absence of start and stop bits, the speed will increase. Timing errors are reduced due to the synchronization. So, this is another important point. When we talk about disadvantages, timing is very important. Accuracy of the received data is dependent entirely on the ability of the receiver to count the received bits accurately. So, this is very important. Receiver should be able to receive the bits and count them very precisely. The transmitter and the receiver have to operate at the same clock frequency, and to attain this, the same clock frequency, this is not easy task. For this proper synchronization, the system becomes complicated. This is disadvantage. Now, when we talk about the serial communication protocols, by protocol we mean there must be some set of rules agreed by both the sender and the receiver. What are these rules? That how the data is packed, how many bits constitute a character, when the data begins and when it ends. So, all these rules are well defined according to different protocols, and hence the different protocols are named according to that. We will see in further lectures. So, when we talk about the serial bus communication protocols, means these protocols, these set of rules are defined for the serial transmission. The exchange of data bits in microcontroller is done by some set of defined rules known as communication protocols, and if the data is sent in series, that is one after the other, then the communication protocol is known as serial communication protocol. So, this is the term derived from the serial transmission. So, as there is a parallel transmission, similarly there is serial transmission, and the protocols that define the serial transmission are known as the serial communication protocols. So, according to these protocols, the data bits are transmitted one at a time in sequential manner over the data bus or communication channel in the serial communication. There are certain terms related to the serial communication. One is the baud rate, which defines the rate of the change of signals within each time unit, that is within each second. Suppose there is 9600, 1200, 2400, these are the different rates for different communication systems. This is known as the baud rate. When we talk about the framing, it means how many data bits are to be sent from receiver to transmitter to receiver in the one unit. So, that is known as the framing. It can have the 5, 6 or 7 bits or the 8 bits as a general term. When we talk about the synchronization, there are certain synchronization bits which are to be added to the data to attain the synchronization between the transmitter and the receiver, and that is very necessary. For example, there are start and stop bits that introduces a synchronization. When we talk about the error control, that means there must be some scheme to control the error, to identify the error. Parity is one way for that. There can be even parity, there can be odd parity. When the number of the ones in the data that is sent from the sender to the receiver is even, that means it is having the even parity, and when the number of the ones is odd in the data, that means the odd parity. So, that is all for the day. In the next lecture, we will see the different communication protocols. Thank you.